Welcome to my video on drying with anhydrous agents. So you would use anhydrous agents to remove trace amounts of water from solution in order to isolate a specific compound. Drying agents are anhydrous inorganic materials that favorably form hydrates. And you would use this in cases where there's another solvent and you're trying to remove water from it. Examples of these solvents would include diethyl ether, ethyl acetate, dichloromethane, hexanes, and more. You would use these in the process of a workup. So first you would go and conduct a reaction, perform extractions to purify the product, and then you would go and use the anhydrous agent to remove trace amounts of water from the solution, leaving the solvent and the product. And then you would go and remove the solvent with a rotovap. So again, drying agents are anhydrous inorganic molecules that form hydrates. So it's a molecule that does not have any water in it that then is able to go and bond with a lot of water and remove it from the system. You would use these in cases where polar solvents dissolve readily in water. So like those examples we discussed before. But you may not want the water because it could interfere in reactions or potentially interfere when using different types of machines to identify products or solvents. So there's several different kinds of anhydrous agents. Magnesium sulfate is kind of the go-to drying agent because it works quickly, holds a lot of water compared to its mass, and the hydrates are notably chunkier. There's some downsides to it, but we'll get to those later. Also, some examples are the CaSO4, which is special because it's blue when it's dry, but then when it soaks up water, it turns pink. Other examples would be Na2SO4 or CaCl2, where the granules are not easily dispersed, like the magnesium sulfate, and so the solutions can be easily decanted. And then other substances also can be easily manipulated in a pellet or rock form. With the solution, so when you're actually starting the process, with this, you would put the solution in an Erlenmeyer flask and then check and see if there's two different layers, if it's hetero or homozygous. If it's heterozygous and there's a layer of water in the solution, go ahead and just pipette as much of the water out as you can, just so that the anhydrous agent can be more reasonably used. Then you would add just enough drying agent, but you would add it slowly in small increments, swirling the solution to mix each time. Again, some of those changes could happen, like the hydrates may change color compared to the dry form, or generally, more often, they'll clump into large chunks. Sometimes they'll cling to the glass as well. So continue adding this drying agent until if the particles are large, chunky, clumping together in larger amounts than they would normally be on their own. If the particles do become more loose and fine, you're nearly there. If it's cloudy, that means that there are still more particles that are out there floating around. So continue to slowly add, but maybe in smaller increments. The dry solution should be totally clear. But in instances where you're using Na2SO4, it can take a bit of time, so maybe wait an additional 5 minutes. When the solution is dry, go ahead and separate the drying agent from the solution, generally by just decanting. That is, pour the solvent and the desired product into a round bottom flask, leaving the anhydrous agent behind. Or because MgSO4 is such a fine powder, the solutions must be filtered. Since we're back to it, some of the downsides are that MgSO4 is so fine that it needs to be filtered. Plus, it does tend to absorb product. Remove any remaining product from the agent by rinsing the drying agent with fresh organic solvent, and then adding that rinse to the flask with the solvent you'd earlier poured off. That helps to rid the drying agent of any product that still might be clinging to it. And then you can remove the solvent with the rotovap. So thank you so much for watching my video. Have a great day.